Let's solve some of the examples that we discussed yesterday using the graphing calculator. For example, in the video prior to this one, I solved the linear equations y minus x equals 3 and x plus y equals -1. We found the solution to be x equaling -2 and y equaling 1, or the ordered pair, parentheses, -2, 1. This is where the two lines intersected. To find this solution on the graphing calculator, we must follow the following steps. Solve each equation for y. So that's the first thing that I did actually on the video prior to this one. And I got that y was x plus 3, and the second equation was y equals -x minus 1. So go to the graphing calculator as it says here, and you'll see me doing this, and enter the first equation under y1 and the second equation under y2. So now I'm going to put up the TI-84 plus. And you'll see that when I put the equations in, y equals x plus 3, and going into y2, negative, make sure you're doing negative x minus 1. So if you have a graphing calculator at home, you can do this with me. Otherwise, we've done this lots of times in class. Before we graph anything, we zoom standardize it, zoom 6. So then it starts graphing. Our first equation, x plus 3, is the blue one here. Of course, yours is probably not in color unless you have a TI-84 Silver Edition. And x, y2, -x minus 1, they're in the red. And you can see that, yes, these lines do cross. Then select the graph key, and we did that. You can probably estimate where the intersection point is by looking at the graphs, but need to be certain that you need to use the second trace. So if I want to know exactly, yes, I can kind of tell that that's the point -2, 1 here. But if I second trace, which means calculate, I'm using this upper function here, I'm going to hit number 5, intersect. And it's asking me, is y equals x plus 3? You can see it up here in the top of the window here. Is y equals x plus 3 the first curve or the first line? So entering yes means, hitting enter means yes, that's the first curve. Is y minus the second equation here that I'm pointing to, -x minus 1, is that the second curve? Yes. You can see it over here. Here it is. It's in my y2. So I'm going to hit enter. Yes. Do I want the graphing calculator to guess? Yes. And the solution, -2, 1, does appear. The second equation that I did yesterday, 2x plus y equals 7 and y minus 3x equals -3, we saw that solution was 2, 3, and we did that on the graphing calculator. So I'm going to go to the next page in the notes. If it's a real-world problem, you may need to adjust your window. Instead of selecting zoom 6, the standard window, you could select zoom 10, which is the zoom fit window, and the graph will adjust to whatever your data is. This example is in the textbook, but we're going to do it as well. It's on page 224 in the textbook. Marianne jogged from point P to point Q, while Walter jogged from point Q to point P, where P and Q are approximately 7.5 kilometers apart. So, just to kind of get the idea, here's point P, and Marianne's jogging towards this way. So here's Marianne's direction. Here's point Q. I guess I should put a point there. Point Q. And here's Walter jogging from point Q to point P. So Walter is going in this direction. Point P and point Q are 7.5 kilometers apart. So they are 7.5 kilometers apart when they start. Marianne's motion is represented by D equals 8t. So distance equals 8 miles per hour, perhaps. And Walter is, kilometers per hour, sorry, kilometers, where t is time and d is kilometers. Walter is represented by 2d plus 14t equals 15. T is hours and time, and D is kilometers. So they're jogging kilometers per hour. When will Marion and Walter meet? How far from point Q did they meet? So solve for y and enter the equations into y1 and y2. Well, I don't have a y in here, but I could change this. Distance equals y and time is x, which time would go on the x-axis. So I could write it y equals 8x. And D is y, so 2y plus 14x equals 15. Well, y equals 8x is already solved for y. Solving this equation for y, you get 2y equals negative 14x plus 15. Dividing by 2, you get y equals negative 7x plus 15 halves. I'm just going to leave it 15 over 2, since that's how I'm going to put it into the graphing calculator anyway. Solve for y and enter the two equations into y1 and y2. So using the graphing calculator, y equals, I have to clear that and clear that. So everything's cleared. I'll press my history here so you can see what I'm doing. So in y1, I'm going to do y equals 8x. So 8x. And toggle down. y2's equation is y equals negative, watch the negative, 7x plus 15 halves. Well, fractions go in as division. So 15 divided by 2, that is 15 halves. Close it in the parentheses. So I have my two equations. I'm going to hit zoom 6, the standard window. And it will start graphing here. My first equation, y equals 8x, is a very steep line. As you can see, it's a positively sloping line. And y equals negative 7x plus 7 halves, or 15 halves, 7 and a half is my y-intercept there. So the red line is the negatively sloped line representing Walter. So where do they intersect? Okay, well, I'm going to hit my second calc button. I want to hit intersection. I could toggle down to highlight 5 or just hit the number 5. Is y equals 8x my first curve? Yes, because in the real world lines are not straight. They are curves. We live on a sphere, or almost a globe. y2 is negative 7x plus 15 halves. Is that the second equation? Yes. Do you want the calculator to guess that intersection? Yes. So the intersection is x equals 1/2 and y equals 4. So x equals 1/2 and y equals 4. Didn't see that on the table here. As I'm looking at my table, as you can see here, I only have values of x that are whole values. So, and it's kind of hard to tell that they intersect, looking at the graph here, my finger's pointing on the graph now, that they intersect at 1/2. So I'm going to go back to, and I did find it through using the intersect function of the calculator, the zoom trace, second trace, which is calculate 5, is the intersection function of that. So I'm going to go back to the notes, minimize my calculator here, and my solution was when x equals 1/2, y equals 4. Well, when the time was a half of an hour, the distance was 4 kilometers. So when will Marianne and Walter meet? They will meet in a half an hour. Or I could say 30 minutes if I wanted to, or a half of an hour later after they've started running. And when it's, the distance is 4 kilometers, half an hour later and after 4 kilometers has occurred. When will Marion and Walter meet? They will meet 30 minutes later. How far up from point Q did they meet? From point Q, Oh, 4 kilometers from point Q. So if you add 4 kilometers from this, that would be at the 3.5 kilometer mark, right? So they will meet 30 minutes later and at 3.5 kilometers from point Q. So I'm answering both parts of the question. How far from point Q? Well, 4 kilometers into the race, they are 3.5 kilometers from point Q. So after 4 kilometers and 30 minutes, they will be 30 minutes later and 3.5 kilometers from point Q. Number 2, 2 cyclists are traveling along a track in the same direction. So they're traveling in the same direction, these 2 cyclists. Their motions are described by the linear equations d equals 10t, which I can change to y equals 10x, and d minus 8t equals 2, or y equals, moving my 8t's over, 8x plus 2. Where t is the time in hours and d is the distance from point A on the track. D is the distance from point A on the track. When will the cyclists meet? So one cyclist had a little bit of a head start, plus 2, going at a slower rate. The second cyclist started at 0 and going at a faster rate of 10. I don't know if it's miles. Miles. D is miles, yes. 10 miles per hour. The other cyclist, the second cyclist, is traveling at 8 miles per hour, but started 2 miles ahead. 2 miles ahead. So putting my equations, y equals 10x and y equals 8x plus 2, using the graphing calculator, again, go into my y equals 10x. So I'm just going to write right over the top of this, and it will go right over the top, y equals 10x. However, the next one I am going to clear it, and that equation is y equals, what was that equation? Y equals 8x plus 2. So y equals 8x plus 2. I've already zoom standardized it. So I'm going to hit graph. It will automatically graph them. And you can see that this person started at the origin here, the blue line, and the other person started a little bit ahead, and their lines almost look like they're overlapping. It's very hard to see. But I can see on the table here, after x is 1, so I can see it right here on the table. I'm pointing to it right here on the table. When x is 1, y is both 10 for both of those. So the point 110 is their intersection. Or, yes, using my second trace, I'm going to find their intersection. 10x is the first equation, yes. 8x plus 2 is the second equation, yes. Do you want me to guess? Yes. When x is 1, y is 10, which we see right here on the table of my graphing calculator, which is on the smartboard here. When x is 1, y is 10. So going back to my notes, when x equals 1, y was equaling 10. So the point when t equals 1, distance equals 10. So when will the cyclists meet? They will meet 1 hour later. One hour later at mile 10.